Hello guys, in this videos I will introduce how do I modify the tutorial transformer. The modification is in order to match my usage of this power supplies is for driving this type of large current DC motor, and originally it was driven in 8.5 DC volt, and current draw is around 9 ampere, something like this. And I found the power is not enough. I want to increase the voltage a little bit, and this DC voltage originally is around 8.5 to 9 volt. I want to raise up to 1.5 volt, and also maintain the current flow same. That is around 9 to 10 ampere. That means the power draw from this transformer will be increased, but just a little bit, so I don't care too much if it can withstand or not, or if it's too much heat, because I driven this motor not continuously, just for around half minutes so, and stop. And in order to increase this transformer output voltage, there is a lot of methods nowadays. For example, I can use this type of switching power converter to step up the voltage or step down. And the purpose I don't use this because I have tried it and not success, because when the motor is under the loading, the current draw is large, 10 ampere, but this type of converter, it has the spec also more than 10 amperes, something 15 amperes, but in actual usage I found the internal resistance of this switching power is higher, and when I step up the voltage and drive this type of motor, when under the loading, the current draw is lower than the original one, so I can't use it because the internal resistance is higher in here than in here, so I give it up. Then I'm now going to modify this by raising its output voltage by 1.5 volt. Just not very big, is 9 volt output. 2 times 9 output is around 100 VA transformer. And I will tell how I will do it. These videos I want to introduce my methods to modify the transformer. This is a tutorial transformer, and this is 2 by 9 volt. I think is 16 VA, and I want the transformers a little bit higher voltage. I want it in 10 volt or 11 volts, and that kinds of voltage I can't find it in the market. So I originally used this transformer. So I want to modify it so I can use it again. Now this tutorial transformer, I think it's easier to be modified than the traditional EI tap transformer. I try to wrap some wire on it and until this at the voltage at the coil is of 1 to 2 voltage, then I will succeed and connect it to the output light. And since it's 2 by 9 volts, I need to wrap this 2 coil light, and the copper coils I took it from this component. This PC board comes from a speaker and is a filter for the high pass of low pass filters, and for the speaker high frequency and the bass. Disassemble it and take out the coil, because this I think is almost 10 ampere. For the one coil, one copper wire is not enough, so for each line I need 2 coil. So here you can see I have 2 coil and 2 coil for the winding. And I start to wind it up. Firstly, I need to use the red and black color to mark on the copper light all along them, so I can identify which one is the first line, since there are 2 lines, 2 by 9 volt. Now is in the midways of the assembling, and you can see for this copper wire I tap on here or around here. So during the winding is more neatly, and after it winded on here, I take out this tab, and it must be noted this winding is radial out, so they are lined up inside here, and then radial here, and separate more here. And it's not bad to have 2 thin wire than one thick wire, because it makes it more flatted and not so bulky, and also easier to wind it. More thin wire is more flexible. And now I count this. I had winders 15 coil here, and there is no knowledge of how many coil that originally there, so it's just still a guessing. It is just a guess if it succeeds to have 1.5 to 2 voltage here, and after all assembly I check the voltage of this output coil voltage, then I have the actual reading, and I will need to take some tuning. So let's see it. Now it is completed, and here I connect to the board, and I have two wire, two lines in and out, and each line consists of two thin wire. So when I measure this line and this line voltage, if I find is 1 to 2 volt, then it's okay, as well as this. And something you must need to consider in choosing the copper wire that is coating on there. Don't damage this coating during winding. Don't turn the wire to sharp angles, or the coating will be peel off and short circuits will happen. And I use this. There is different specs for this coating on the copper wire. I disassemble this wire from this speaker frequency divider, and I think although it is not very suitable, I think it can be used. Some coating have higher temperature spec, and I think it's lower one. But anyway, I will not load this transformer too heavy, or it will not have so high temperature. And second thing is about this transformer, the second thing is to take care the electromagnetic fields flow up inside this core, and if we put too much loading on the output, the core will be saturated with the too much magnetic field flux, and it will damage the core or will cause the overheating. So we must not load too much on out. When we increase the output voltage, the output currents cannot be too high, otherwise the happenings occurs. And for this transformer, it's poor that it has no power spec reading on it, but I guess it is a 100 VA and 2 by 9 volt, and if I remember it's 100 VA, and when I use 9 volt output, I can get 10 to 11 ampere. So I will use this rating for later on the usage. Here I draw the diagram, 2 by 9 volt center tap here, and the added 2 coil here, and I draw the coil in this direction, and the same as the original coil direction, but actually this may not be that, but it doesn't matter. And I label it Q1, Q2 is original output line, and added A1, AI and AO, BI and BO. And here I also mark this is Q1, Q2, and this is the ground center tap. and AI is here, and AO is here, BI is here, BO is here. Now I turn on the power and I can check the voltage. First I check the original voltage here. It's 9.8 volt. And then AI and AO, this is AO, this is AI, is 4.1 voltage, and BI and BO, and it's also 4.1 volt. And I can write it down. This is 9 volt, and this is 4.1 volt, and so that's here. And I had counted the number of turns is 21 turns, same as this one. Actually, I don't need too much this value. I will tap out in 3 or 4 steps here, so I can get 1 volt in step. I firstly need to identify if I mark the label here AI and AO is correct or not. Here is assumed that this is AO and the coil is in this direction, and later on I will connect this together. But if this is correct, then the voltage will be added on 9 volt. Otherwise, if this are put wrongly, then the voltage will be reduced. There's 9 volt reduced 4 volt, that means only 5 volt. And also, in most case, it will overheat or make the humming noise on the transformer. So I need to check it. I connect AO to Q1. This is AO, and Q1 is here. And then I measure the voltage, measure AI and Q2 or ground, AI and ground, and see the voltage. Here is ground, is AI, and I found is the voltage increase to around 14. That means my connection and identification of labeling identification is correct. And similarly, this will done again. For the BI and Q2, BI is here, and Q2 is here. Then measure the ground and PO. Here is ground and PO. And I found it's also 14 volt. That's correct. Okay. Here I make the connection here. These are this area. After I confirm the labeling correct, in the direction of coil here correct, I make connection here, and also this here. And as I measured, there is 4.1 voltage here, and total number of turn is 21, and each turns you have 0.2 voltage. And in my consideration, I need to have around 1.7 voltage, so I need to have 8.5 turn. 8.5 turn times 2.2, 1.7. So I need to unwind some coil and then make the tapping on the 8.5 turn location here, and then connect all the lead wire here. To make this, I need to scrap all the coating and also soldering there, as there is exposures of the conduction surface. I need to tap here. I use the high temperature taps here. This tap here, it's better to use this tap. And now all is done, and I can connect the voltage and power, and then I measure the voltage here. One is ground, one is output here, and it will rise to 11.5 volt. Originally is 9.8 volt. Here is a little bit higher, and this the value match my calculation here. Is something 11.4 or 5. Originally is 9.8 volt. Here I make the connection here. These are this area. After I confirm the labeling correct, in the direction of coil here correct, I make connection here, and also this here. And as I measured, there is 4.1 voltage here, and total number of turn is 21, and each turns you have 0.2 voltage. And in my consideration, I need to have around 1.7 voltage, so I need to have 8.5 turn. 8.5 turn times 2.2, 1.7. So I need to unwind some coil and then make the tapping on the 8.5 turn location here, and then connect all the lead wire here. To make this, I need to scrap all the coating and also soldering there as there is exposures of the conduction surface. I need to tap here. I use the high temperature taps here. This tab here, it's better to use this tab. And now all is done, and I can connect the voltage, power, and then I measure the voltage here. One is ground, one is output here, and it will rise to 11.5 volt. Originally is 9.8 volt. Here is a little bit higher, and this the value match my calculation here. Is something 11.4 or 5. Originally is 9.8 volt. I send biders into the electrical boxes, power supply box, and here is the output. I connected the multimeters here, the output, measuring the output voltage. And firstly, I load the no-load motor. See what the load and what the voltage is. And here is another motor with fan there. This is the fan loading. Measure the current. Normal current is 1.5 ampere for this motor. And here is the fan loader motor. I can still, actually I will apply in another machines and it will load us much more. I think I can go to 10 ampere. Thank you for your watching. If you like the video, please thumbs up and also subscribe.